Hello everybody, welcome to Subotica Tech. My name is Livia Sedmina, and today I will give you a tour of our science wall, which is actually a list of the superheroes of science, some of the superheroes. You will find out how people made their inventions, what the knowledge is basically that we are teaching here at the college today. Without their work, without their inventions, our college would not be possible. So let's start. At this point, I have to be honest, we are alone pretty much in the evening at the college, and I'm going to take my mask off just so you can understand me better and I can actually see something in my glasses. So there you are. It's very easy to say that most of the beginnings of science came from Egyptians, came from the ancient Greek, and that's why we started with Archimedes of Syracuse. He gave us stuff like, how big is a sphere? How can I calculate the volume of a sphere? But then again, every time you get into an elevator, every time when you go to a fun fair, like a really fancy one, when you go with the loop, whee! He came up with the basic science to do that. And just to show how important he was even in his time, he was killed by Roman soldiers when a Roman general found out about this. He ordered that Archimedes be given a proper grave, and on his grave there was a cylinder, and within that cylinder a sphere, to acknowledge his contribution to today's mathematics. And he was also in Big Bang Theory when Sheldon Cooper tried to change a tire. So he is still significant. But then again, not all knowledge came from Europe. As a matter of fact, Muhammad ibn Musa al-Khwarizmi is one of the Persian scientists, Persian mathematics, a polymath really. He was active in astrology, astronomy. He came up with basic mathematics, and one of his written works, and I'm going to read this incorrectly, Hisab al-Jabr wal-Muqabala, gave us the word algebra, which we still use in every maths class today. Nicolaus Copernicus is the reason why we know the solar system as we know it today. That it's not the Earth, which is the center of the solar system, but in fact the sun. Have you got any idea what a novel, radical idea that was back then? But to remember his significance, even on his gravestone, there is a model of the solar system as Copernicus defined it. So he is who gave us astronomy as we understand it today. I'm not going to talk about Leonardo da Vinci because most of us know a lot about him. What is probably important is that he produced ideas and sketches of flying machines, of tanks, of early diving equipment. He was way ahead of his time. Then again, he was also an artist. I'm going to move on now, leave out Galilei, although he definitely deserves to be on this wall, but I am going to talk about Newton, because this is a technical college. He gave us probably the most important scientific work, the so-called Principia, or Principia, in which he defined basic laws of motion. In very simple terms, and I'm reading this out, any object, it moves in the direction it is pushed. And it will keep moving, that's the second law, in a straight line until it comes up onto an obstacle. And the third rule of motion is that any action has an equal reaction. What is probably worth mentioning is that Sir Isaac Newton was the first scientist to receive a knighthood, the Sir part, for his contribution to science. That didn't happen before. And we are still in the United Kingdom, but we moved to Scotland. If you ask any Scottish person who a significant Scotsman is, what will be up there with the most important ones? Why what? Because he made the steam engine. He didn't make it, first of all. There were people before him, Thomas Newcomen, most importantly, who had already created the steam engine, but Watt developed it further and he put it to commercial use. So today, when you mention the word steam engine, most probably you will connect his Watt's name with the steam engine. There's a Norwegian electric ferry, so a ferry running fully on electricity, under the name MIV Ampere. Why? Because André-Marie Ampere is practically the father of electricity. All his work was done in the fields of electromagnetism, electrodynamics, and in his honor, or what shows his contribution, is that on the Eiffel Tower there's a total number of 72 scientists. His name is one, and obviously we still use ampere as a unit. Moving on, we come to another great of electricity, of electrical science, which is Michael Faraday. You have all heard words, the terms electromagnetic induction, electrochemistry, electromagnetism, or the Faraday cage itself. These are connected to his name, electrolysis. He represents a unique mixture of physics and chemistry, and interestingly enough, he is also the one who gave us rubber balloons. So now we come to a completely new territory. Mathematics is obvious, yes, everyone was a mathematician back then, but Ada Lovelace is a unique person. She was the daughter of Lord Byron, the celebrated English poet, although she never knew her father. But the family was sort of afraid that she would inherit these very radical, revolutionary, poetic stances. So instead, they actually made her learn mathematics, and she loved it. She conversed with Charles Babbage, who was, in his time, the inventor of the so-called analytical engine, or difference engine. They managed to calculate, which is a huge deal. The machine managed to perform basic operations, and Ada was left to take notes of this engine. So she understood it as much as the inventor himself, although it took a couple of hundred years until her contribution was recognized. She died very, very young, and then she was buried next to her father, whom she never knew. So altogether, Ada Lovelace is a very unique character in the history of computing, as we know it today. Other great people. Mendeleev obviously gave us all the periodic table. Without him, we would be still struggling with the names of elements and this whole system of classification. However, I'm going to turn now to Eötvös Loránd. Eötvös Loránd is primarily at the moment known as the person for whom ELTE University in Budapest, Eötvös Loránd University in Budapest, is named. He was a Hungarian physicist, and although never patented in his name, but he developed the torsion balance, later called the Eötvös pendulum, used in oil fields. That was a reminder, and also a reminder that not all scientists are just bland, reading, calculating, boring people. Eötvös Loránd was an avid mountaineer. He was a noted mountaineer Europe-wide and had quite a few first climbs in the Alps. Nikola Tesla, it's very difficult to say something new about Nikola Tesla. Most of us know him from school. We know that because of his contribution to science, we have things like the Wi-Fi, alternating current. We also have fantastic movies in which David Bowie and Nicholas Hoult and even Goran Višnjić played Nikola Tesla himself. So as much as you can get a colorful and very, very peculiar scientist, Nikola Tesla is just that. I'm sure that you all recognize this wiry silver hair. Only one person had these features, these facial features. This is obviously Albert Einstein. Well, go back to the beginnings of his career. He was a university graduate, but he was working at the patent office in Bern, about an unspectacular job as you can get. He was a technical examiner 3rd class, but in 1 year, he managed to write not 1, not 2 scientific papers, but 5 scientific papers sent to the noted journal, scientific journal Annalen der Physik, and at least 3 of those papers literally changed the face of physics. In those papers, he explained Brownian motion, which basically confirmed the existence and movements of atoms, as well as explained the nature of light, for which he, 21 years later, received a Nobel Prize. Obviously, his most famous and most noted theory is the theory of relativity, which came some years later. E equals mc squared is just about the only equation that every one of us knows. But for all his scientific work, I think Albert Einstein had a huge impact on physics, which we are still grappling with today. We move on to another person whose scientific contribution wasn't necessarily recognized at the time, or if so, then it was indirectly and certainly not made public. Alan Turing designed the first commercial computer, one that could compute and eventually crack the Enigma code during the Second World War. Arguably, this is what helped win the war and helped understand and keep track of German communication during the war, German coded communication during the war. What we know Alan Turing for today is the Turing test, which means that you can run a Turing test on me and then decide if I am a human being with human intelligence or if I am artificial intelligence, which means a robot. Well, we just have to run a test, but I think I'm human. I know I should be saying stuff like read up on Alan Turing on the internet and everything is written up in scientific journals. But actually, what's really fun is to watch films such as Imitation Game with Benedict Cumberbatch, which actually explains a lot about Turing as a person and his contribution to computer science as we know it today. Right, so now that I've talked about a lot of scientists, hang on a second, have a look at your computer. Do you know what's in it? It's got all the classical parts. It's got the CPU unit, it's got the ALU unit, it's got a control one, it has a memory, I'm sure it's got registers and inputs and outputs. And do you know why? Because of John von Neumann. He is a Hungarian-born scientist, mathematician, who developed the so-called von Neumann computer architecture, which we still use today, which is the basis of today's computers, yours, mine included. And why do you think he was able to do that? One thing that von Neumann has a lot in common with all the other scientists that I've talked about now, his deep knowledge and love for mathematics. He was a math prodigy. He learned about calculus as early as 8 years old, and he was well-versed in calculating numbers, multiplying them, dividing 4-digit numbers by heart, although in America, where he spent most of his working life, they actually considered him a Martian for that. Nevertheless, he makes our computers still look the way they do and still operate with the same basic system. Okay, now you've checked your computers, now check your mobile phones. Do you have a Bluetooth connection? I'm sure you have a Bluetooth connection, I do. The Bluetooth connection is basically a much, much, much further developed invention of this lady, Hedy Lamarr. I'm going to introduce you to a proper Hollywood actress. She is Austrian-born. Her official name, the one she was born with, is Hedwig Eva Maria Kiesler. She played in more than 30 movies in the Hollywood era. And She was a bona fide inventor who helped invent the spectrum technology. What exactly is that? Well, during the Second World War, they had torpedoes. Torpedoes worked on radio signals, which could be easily jammed. So she and her collaborators came up with the idea that if you jam a signal not once, but if you make it hop often, for example 88 times, then it becomes much more difficult to jam. This was the basis, and this made torpedoes actually reach their original targets. The same technology is used in our GPS systems, partly in Wi-Fi systems, and I said before, Bluetooth systems. So, Hollywood star, and we still use her technology. Although, sad to say, she wasn't recognized for her invention until 1997, pretty much before her death. Margaret Hamilton is the reason why software engineering, software development is cool. It doesn't get much more cooler than Margaret Hamilton. She was a software engineer. Actually, she came up with that term, so we use it because she invented it. And she primarily wrote software for the Apollo program by NASA. That is the program that put people on the moon. Her software helped make the lunar module land safely. And then, in case you were wondering if it gets any cooler, yes, she's got her own Lego set. So if you're looking for a cool Christmas present, go find the Women of NASA Lego set and see if that doesn't make software engineering make it sound really, really fancy. If you want to find out more about science, read up, find out about these people's inventions, or see how their inventions are still relevant today, read up on the internet, or simply come and check us out here at college. Thank you.